So now I want to look at this one here and want to see how do we perform the integral here, the integration. So for this one here, you also have to just have a bit of insight on how it works. And you have to see that if you were to differentiate the argument of the root, it actually reduces to give you sign. So let's demonstrate. So here, to perform the integral, we have to let u be equal to the argument of the root there, which is 7 minus 2 cos theta. And then when we differentiate, yes, we're using the algebraic substitution here. Yes. So when we differentiate with respect to theta here, the first part will be a 0. Then we have -2, a constant. The derivative of cos theta gives us what? But negative. So the derivative of sine is positive cos. The derivative of cos is negative sine. So this now, for cot, it's actually sine that tan that we actually talk about there a lot. The derivative of tan is sec squared. Okay, so for this one now, we now end up with du d theta. The negative and negative gives us plus, but this is now 2 sine theta. Then now we want to make d theta the subject of the formula. So I have du over 2 sine theta equal to d theta when you cross multiply here. Now, let's see if indeed our substitution works. See, the concept is that when you substitute u in the expression, the variable which was initially present must disappear. So here you have sine theta. This is root. Remember we said 7 minus 2 cos theta is u. So this is root u. But for d theta, we'll substitute it with this expression. So in place of d theta, we will put this. So what you quickly see here is that the sine theta will cancel with the sine theta, leaving us with only the root, the integral of root u, and then du over 2. 2 is a constant, so it doesn't matter even if we pull it out. But of course, since it's in the denominator, it's over 2 there. And then this is now the integral of root u. Now this is basic. So to integrate this, I'll first express the u, the root there, as a power half. Okay. Right. So here, of course, I just changed my root so that I get as a power half there. We're okay with that part, right? Okay, so we started from somewhere here. So here I was saying that the 2 being in the denominator, being a constant, doesn't matter whether it is inside or outside the integral. So I basically just moved it outside the integral. But since it is in the denominator, I wrote it as 1 over that 2. Then here, of course, the sine and the sine cancelled, leaving only du over 2 and the root there. Okay. So this is how we ended up somewhere here. We're okay up to here? Okay, so having expressed the root as a power, we can now perform the integration. So the 1 over 2 I'll maintain here, and then whatever I'm integrating, I'll put there. So first multiply the power down, which is, sorry, we don't do that. That's differentiation. So when we are integrating, here, add 1 to the power. So the power is half. When I add 1 to half, I get 3 over 2. All right, so yes, when I add 1 to the half there, I get 3 over 2. Now the 3 over 2 becomes the new power, and the 3 over 2 have to divide here. So of course, since we're done integrating, we'll say plus the constant c. Here now we just have to simplify this. Writing the fraction here, this will end up being 1 over 2. The 3 over 2 changes to 2 over 3. And then this is u to the power 3 over 2 plus c. So that the 2 and the 2 cancels. This will be 1 over 3, u to the power 3 over 2 plus c. Finally, bringing back what u is, we defined u as the argument of the root there, and we said u was 7 minus 2 cos theta. So we can now finalize this and say this is 1 over 3. In place of u, we'll put that 7 minus 2 cos theta, and then to the power 3 over 2 plus c. So this becomes our overall solution.